Today we are going to start a new topic, that is multiplication of vectors. Now there are two types of multiplication of vectors. Number one is a dot product. Or it is called scalar product. The second one is vector product. Or it is called cross product. Now we will discuss these two types of product one by one. At first, we shall start with dot product. If there are two vectors, A vector and B vector, inclined with each other at an angle theta, then their dot product is represented by A vector dot B vector equal to the product of magnitude of both the vectors and cosine of the angle between them. Hence, A vector dot B vector is equal to the product of magnitude of both the vectors, A vector and B vector, and cosine of the angle between the two. This method is called dot product. Now we can define this dot product in another way. Take an example. If this is A vector and this is B vector, inclined at an angle theta with each other. Now this resolving this B vector into its two rectangular components, one along horizontal direction B cos theta and one along vertical direction B sin theta. Now if we take the product of these two, A vector dot B vector, that is equivalent to the magnitude of A vector into this component B cos theta. That is equivalent to magnitude of A vector into component of B vector in direction of A vector. Similarly, if we write this as A vector and B vector and we find out the components of A vector, one along B vector, that is A cos theta, one is perpendicular A sin theta, then the product of these two, B vector dot A vector, is equivalent to magnitude of B into A cos theta, that is magnitude of B into component of A vector. Hence, another definition of dot product is it is the product of magnitude of one vector, either it is A vector or B vector. The magnitude of one vector and the magnitude of component of other vector in the direction of the first vector. So if we take A as first vector, then magnitude of A vector into the component of the other one, B is the other one, so the component of B in the direction of A, and in the direction of A the component of B is B cos theta. So the product becomes A into B cos theta. This method of finding the product of two vectors is called dot product. We will finally find out that the product is in the form of a quantity, scalar quantity. So it is called scalar product. Now we shall discuss about the properties of the dot product. Now if we first of all find out the dot product of unit vectors. Dot product of unit vectors, say I cap dot I cap. Now the method of finding the dot product is we will take the magnitude of these two vectors into cos of the angle between them. So if this is x-axis, y-axis and z-axis, this is I cap, j cap and k cap. Now we have to find out the product of I into I. So the magnitude, we will take the magnitude of I cap into the magnitude of I cap into cos of the angle between them. Now if we take I along this direction, another I along this direction, the angle between them is 0 degree. So this becomes cos 0. So magnitude of I vector is 1 into cos 0 is 1. So this becomes 1. So dot product of similar unit vectors is 1. Similarly we can write j dot j equal to k dot k equal to 1. So I dot I equal to j dot j equal to k dot k equal to 1. Dot product of similar unit vectors is 1. Now if we take dot product of I and j, then use same method, magnitude of I into magnitude of j into cos of the angle. Now the angle between them is I and j, it is 90 degree, it becomes 90 degree. So this becomes 1 into cos 90 is 0. This becomes 0. So I dot j is 0. Similarly we can find j dot k is equal to k dot I, all is equivalent to 0. So from here we can conclude that if two vectors are parallel, then their dot product is equivalent to 1. If two unit vectors are perpendicular to each other, then their dot product is equivalent to 0. We can take another case, third one. If two unit vectors are anti-parallel, that is angle between them is 180 degree, then a vector dot b vector is equivalent to a into b cos of 180, that is equivalent to minus of ab. Now another property is dot product is commutative. That is a vector dot b vector is equal to b vector dot a vector. Now we can prove this by taking an example. Take an example. If a vector is equal to 2i plus 3j plus 4k and b vector equal to I minus 2j plus 3k, then if we find out a dot b, that is equivalent to 2i cap plus 3j cap plus 4k cap dot I cap minus 2j cap plus 3k cap. Now we have already studied that the product of similar vectors is 1 and the product of two different vectors is 0. In the first case we have studied. So we will find out the dot product by this method. We will multiply the quantities of I with I and j with j and k with k. So this becomes 2 into 1 I dot I plus 3 into minus 2 j dot j plus 4 into 3 k dot k. Now we know I dot I is 1, so this becomes 2 into 1 plus 3 into 2 minus 6 into j dot j is 1 plus 12 into 1. So this becomes 8. 12 plus 2 becomes 14 minus 6 is 8. So a dot b comes out to be 8. That is a scalar, that is only a number. So it is called a scalar product also. Now we will find out b dot a. Again we will put the values. For the value of b, it is I cap minus 2j plus 3k cap dot 2i plus 3j plus 4k. I with I, j with j and k with k. So we will get b vector dot a vector equal to 2 into 1. 1 into 2 becomes 2. 3 into minus 2 plus 3 into 4. I into I becomes 1 j into j becomes 1 and k into k becomes 1. So this again becomes 8. So b vector dot a vector is equivalent to again 8. So either we will find out a dot b or we find out b dot a. The value in both the cases is same. So we can say dot product is commutative in nature. Another property of dot product is it is distributive in nature. Distributive means if we find out the dot product of a dot b plus c vector, then it comes out to be a dot b plus a dot c. This nature is called distributive nature. Now we can prove this by taking an example. Now take an example. A vector equal to 2i cap plus 3j cap plus 4k cap. Similarly, b vector equal to 3i cap plus 2j cap minus 2k cap. C vector equal to 5i cap minus 2j cap plus 3k cap. You can take any value by of your own for proving this example. Now we have to find out first of all a vector dot b plus c. So we will put the values as 2i cap plus 3j cap plus 4k cap, that is for a vector, dot value of b. B vector is 3i plus 2j minus 2k, and for c vector it is 5i minus 2j plus 3k. For adding of these two vectors, we will add I with I, j with j, and k with k. So this becomes 2i cap plus 3j cap plus 4k cap dot. Now 3i plus 5i becomes 8i, 2j minus 2j, this becomes 0 as j plus minus k 2k cap plus k 3k cap, this becomes plus k 1k cap. Now we have to find out the product of these two quantities. So I with I, j with j, and k with k. This becomes 8 into 2, 16. I dot I becomes 1 plus 3j into 0j. This becomes 0. 3 into 0 becomes 0. Plus 4 in k into 1k. So 4 into 1 becomes 4. K dot k becomes 1. So this becomes 16 plus 4 is 20. So a vector dot b plus c vector is equal to 20. Now similarly, find out the values of a dot b plus a dot c. Note one thing, that a vector dot b vector plus c vector is equal to 20. Now take the right hand side as a vector dot b vector. So we have to find out the dot product of these two vectors. I am writing directly. 2 into 3 becomes 6 plus 3 into 2 becomes 6 minus 4 into 2, 8. So this becomes 4. A dot b equal to 4. Similarly, find out a dot c. A and C vector. Now 2i into 5i, this becomes 10. 3j into 2j becomes minus 6, plus 4k into plus 3k, that becomes plus 12. 4 into 3 becomes 12. So it comes out to be 16. Now we have to find out A vector dot B vector plus A vector dot C vector. This is the right hand side. So this becomes 4 plus 16 equal to 20. So the value of left hand side A dot B plus C is 20, and the value of right hand side, that is A dot B plus A dot C, is also 20. Hence we can say that dot product is of distributive nature. Another property of the dot product is, if we find out the dot product of a vector with itself, that is, if we find out A vector dot A vector, then it will be equivalent to the square of its magnitude. Now we can prove this by using simple method: A vector magnitude of A into magnitude of A into cos of the angle between them, and the angle between them is 0 degree. So this becomes A square. So A dot A is equivalent to square of its magnitude. In all the cases or examples, we have find out that when we find out the dot product, it comes out to be a number. It comes out to be a scalar. Hence we can say dot product as scalar product. So there are a few examples of dot product. First one is work. That is W equal to force into displacement into cos of the angle between them, Fs cos theta, or work is equivalent to F vector dot S vector. We will study it later on. Similarly, we can discuss about power and other examples we can take. Now, uses of dot product. Where we can use this dot product? The first use is, we can find the angle between given two vectors. Say A vector equal to 2i cap plus 3j cap plus 4k cap. We have taken an example: B vector equal to I cap plus 4j cap minus 2k cap, and we have to find out the angle between these two vectors. Now we know A vector dot B vector is equal to magnitude of A into magnitude of B into cos of the angle between them, and we have to find out the value of this angle theta. So cos theta becomes A vector dot B vector upon A into B, or the magnitude of A into magnitude of B, AB. So we can put the values of these two. A dot B. So when we find out the dot product, we put the values like this: 2i cap plus 3j cap plus 4k cap into I cap plus 4j cap minus 2k cap upon the magnitude of A. Now we know the method of finding the magnitude: taking under root and adding the squares of the coordinates. In the case of A, this becomes 2 square plus 3 square plus 4 square into, in the case of B, it is 1 square, the coordinate of I cap is 1 plus 4 square plus square of minus 2 square. So it becomes, if we find out the dot product, I into I, j into j, and k into k. So this becomes 2 into 1, and I dot I becomes 1 plus 3 into 4 plus 4 into minus 2 upon under the root magnitude of A, that is 4 plus 9 plus 16 into 1 plus 16 plus 4. So this becomes 2 plus 12 into minus 8 upon root 29 into root 21. So theta becomes, theta equal to, we will take this cos to this side, cos inverse six upon under the root 29 into 21. So by finding this value, we can easily calculate the value of theta. Now the second use of dot product is to prove two vectors perpendicular to each other. Now for this, we know A vector dot B vector equal to magnitude of A into magnitude of B into cos of the angle between them. So if theta equal to 90 degree, so the dot product becomes A vector dot B vector equal to A into B into cos 90, and cos 90 is 0. So the dot product becomes 0. So for proving two vectors perpendicular to each other, we will just find out their dot product, and if their dot product is equal to 0, then we can say the angle between them is 90 degree. That is, they are perpendicular to each other. And if the angle between them is not 0, if the dot product is not 0, then the angle between them is also not 90 degree. So we can prove this by taking an example. Now take an example. If A vector equal to 2i cap plus 3j cap plus 4k cap, similarly B vector equal to 3i cap plus 2j cap minus 12k cap, then we will find out their dot product. Now we have to prove that A vector is perpendicular to B vector. We have to prove this. and for this we will find out their dot product. So A vector dot B vector equal to 2i cap plus 3j cap plus 4k cap dot 3i plus 2j minus 3k, I with I, j with j, and k with k. So we will find out 3 into 2 becomes 6, I dot I becomes 1 plus 3 into 2 becomes 6, j dot j becomes 1 plus 4 into 3, 4 into minus 3 becomes minus 12, k dot k becomes 1. So this becomes 6 plus 6, that is 12, minus 12 equal to 0. So A dot B becomes 0, that is their dot product becomes 0. Hence we can say A vector is perpendicular to B vector. So whenever we have to prove that the given two vectors are perpendicular to each other, we will just find out their dot product. If it comes out to be 0, then they are perpendicular, and if it does not come out to be 0, then they will not be perpendicular. Now another use of dot product is to find out the value of unknown constant if the given two vectors are perpendicular to each other. Now in the question you are given that the given two vectors are perpendicular to each other, and we have to find out the value of the unknown constant. You are given with A vector perpendicular to B vector. To take an example, if A vector equal to 3i cap plus 4j cap minus 5k cap, B vector equal to 2i cap plus pj cap minus or plus 2k cap. Find the value given A vector perpendicular to B vector. Find the value of P. Solution we will take as we are given with A vector perpendicular to B vector, and we, in the earlier case we have studied if the given two vectors are perpendicular to each other, then their dot product is equal to 0. So if A vector perpendicular to B vector, then A vector dot B vector equal to 0. Therefore we will put the values of these two equal to 0. (3i plus 4j minus 5k dot 2i plus pj plus 2k equal to 0. We have put their dot product equal to 0. Now find out their dot product. I with I, j with j, and k with k. So this becomes 6. 3i into 2i becomes 6 into 1 plus 4 into p becomes 4p, j dot j becomes 1 plus 5 into 2 becomes 10 minus 10, k dot k becomes 1, and the product of all these is equivalent to 0. So this becomes 6 plus 4p minus 10 equal to 0, or we can easily calculate 4p equal to 10 minus 10 plus 6 becomes minus 4, and minus 4 will be equal to 4 when it goes to this side. So p comes out to be 1. So the value of p comes out to be 1. So we can use this dot product for finding out the value of any unknown constant if the given two vectors are perpendicular to each other. We can only use this method if the given two vectors are perpendicular. If they are not perpendicular, we will not use this method to find out the value of unknown constant.